Hello and welcome to a short tutorial on the use of the Takeoff Performance Estimator for the iPhone. One enters the application by tapping on the icon on the device itself, and we're presented with the home screen for the application where there are four facilities displayed here. The aircraft library, which is where the information is created and stored, the takeoff data where we enter the ambient information for the proposed takeoff, the takeoff summary where we get the results of the estimation, and the information screen, which goes into much greater detail than this short tutorial will, so I encourage you to take a look at that information in greater detail once you're using the system. One envision that we would start using the system by entering the aircraft library and choosing the airplane that we want to fly. Let's assume today that we want to fly the Cessna 172. And here is the aircraft information that was entered into the library, which is basically the standard conditions, sea level, gross weight, performance of the Cessna 172. We can navigate back to the library if we want to look at a different airplane, or we can take a shortcut here to the takeoff data, where we'll see about 6 screens where we enter the atmospheric ambient conditions for the proposed takeoff. Let's assume, for example, that we've got a 2,500-foot pressure altitude, forecasted temperature of 20 degrees. Be sure and use centigrade rather than Fahrenheit, as the screen shows. Let's also assume that our takeoff weight is 2,250 pounds. Notice, by the way, that as we enter the takeoff weight, the system will calculate the percentage of gross weight. It does that in case we have an overweight condition. It will enunciate an overweight condition, and the system will stop until that is resolved. Let's go on and let's assume there's no wind, and so we can use any runway we want. And the takeoff distance estimations for this particular situation are presented here. With 3,700-foot density altitude, a dry concrete one-way takeoff distance required of 983 feet, and plus, using generally accepted factors, we've added a contaminated surface estimations for turf, short grass, tall grass, soft field, or mud. Of course, mud can go out to infinity. So that is a real quick way to see how you can get to the system. Get to the system information. By the way, if we turn the device sideways, we'll see a summary of everything that's in the system, the takeoff estimation on the right, and the information about the ambient data is entered on the left. So let's assume that we get closer to takeoff and we find that the conditions may have changed. So let's go ahead and enter the takeoff data again. We discover that the temperature has gone up to about 23 degrees, and the passenger is bringing us some luggage, so we're up to adding 50 pounds to that. We've got an 18-knot wind, for example, and it's coming out of 190. Because we have a wind now, we'll actually get presented with a wind graphic after we select the runway, 16 here in this case, and we see that we've got a right quartering headwind. The headwind component is 16 knots, the crosswind component being 9 knots. There's our total wind information that we entered. Because we're missing that convenient keyboard that we've been using in the past, let's go ahead and the next key is at the upper right. Let's assume now that there's an obstacle there of 20 feet on this particular runway, and now we have a distance required with a change in temperature. Now it's a little bit over 4,000, 1,247 feet, and there's the contaminated surface, and we're reminded of what the wind components are for headwind and for crosswind. And there, of course, is the summary information that we saw before. Now, the key aspect of this is, of course, where did the information come from that we used to create this data? And what we'll do is go into the aircraft library and create an airplane. So using the standard iPhone gestures and symbols, we're going to go ahead and add a Cessna 182. And here, for example, we'll type aircraft tail number will be November, let's call it 182. Let's see, November 11123. So that'll be 11112. The type of the airplane, Cessna 182. It asks here if the POH uses tables or graphs. So graphs, of course, we're familiar with from Piper and from perhaps Diamond, that would be these types of graphs here. And the POH gives us takeoff performance information using tables for the Cessna, so that's what we'll be using for this particular entry. So we're going to say that as yes. We come back to the convenient keyboard that we saw before with the 10 numerals plus the next key and the backspace key for revising previously entered information. And the gross weight of the Cessna 182 we see from the POH is 3,100 pounds for the takeoff gross weight. So we'll enter that in there. And the no obstacle distance and the 50-foot obstacle distance we see as being 805 feet and 1,515 feet respectively. So we'll go ahead and enter the 805 in here for the no obstacle distance, and we'll enter the, let's back up and make that 805 just to be really precise. And the 50-foot obstacle distance of 1,515, we'll enter that there. I like to have as a safety factor just to make sure the math doesn't give us ridiculously short distances. I like to have the lowest charted distance that's in the whole POH for takeoff, and we see that as being 445 feet. So just for safety reasons, I'll go ahead and enter that in there. And the liftoff speed we're going to be using is the liftoff speed that also comes out of the POH. That, of course, is being 50 knots. For the Cessna 182. So we'll enter 50 knots there. And now we're being asked for this headwind factor. The headwind factor comes from the notes that's also in the POH. We see that we can decrease the takeoff distance by 10% for each 9 knots of headwind, but we must increase the takeoff distance by 10% for each 2 knots of tailwind. So we're going to go ahead and enter that information here. 10% for the headwind for each 9. Notice there's a fixed decimal point in that field, so 90 gives us the 9. And for the tailwind, 10%, and it's 20, which gives us 2.0 for the 2 knots of tailwind. We have to get good density altitude calculations. We're going to go ahead and use the wingspan of the airplane. It does some aerodynamic calculations for us. If we enter the wingspan of 36 feet, we'll enter that in there, 3600. And that is compared to and using the formulas that are in the system. We also need the wing loading of the airplane, which is 17.8. So 1780 for that. And then for a variety of reasons, I like to add a little safety factor in there, and primarily it's because all these numbers are short field takeoff numbers, which are rarely used. So I'll enter a safety factor in there of at least 10% just to be sure that I've got something safe. Here I'm allowed to go in and and take a look at the data and edit it as I wish, audit it as I wish, and if I want to save that airplane, I can go in and save it, and that's how I've just created this new airplane. Going back to the home screen, I can enter the takeoff data, and I want to be sure if I change airplanes to have another look at the takeoff data to make sure that the weight at least is appropriate. Now let's say we weigh 3,050 pounds now. We'll find that when we go in and take a look at the takeoff summary, there's our new information for our new airplane with the headwind and tailwind information, and there is the summary information for that tail-numbered aircraft, which is a real nice way to get a good performance estimate. So thank you for watching this overview of the iPhone Performance Estimator. A good way to get reasonable estimates. If the actual takeoff distance estimate is critical to flight safety, by all means, use the POH for this purpose.